serum to serum English. So this is a combined presentation, yes, with Dan here. And I will first present what serum is doing, but also how to use 3D printing of bioceramic to regenerate the bone of the patient. So a few words first about Serum. Serum is a kind of spin-out company from Belgium, coming out of CIVIS, so research center, dealing with 3D printing since 1989, so it's quite old, dealing with 3D printing. And I decided to develop the technology coming from CIVIS and to propose our service in 3D printing of ceramic and bioceramic. So our main goal at Serum is a contract manufacturing organization in 3D printing of ceramic. Let's say that we are a subcontractor of different manufacturers to develop and produce different kind of device made of ceramic, including implants, surgery tools, filters, cell culture support, and other medical devices. We have also an industrial activity, but let's say it's out of the scope today. We are ISO certified, the last one, 2016, so we are quite proud of it. And if you are here, you know all the advantages, or maybe nearly all the advantages of 3D printing. So 3D printing, of course, the advantage is freeforming, making complex design, patient-specific design, custom design, mainly in the medical field, of course. But we can also manage 3D printing by control the porosity of samples, but here of implants, reducing the assembly, easy prototyping. But now, today, we have more and more high-performance material, high-performance polymer, high-performance metals, and here let's talk about high-performance ceramic. First of all, first reminder about our bone, because we will talk a lot about bone during this presentation. All bone are made of two phases. One organic with cells, blood vessels, and so on, and the second one made of inorganic. And the inorganic is bioceramic. It's made of calcium phosphate. It's a mix of both. So all bone are made of ceramic, and we can make hydroxyapatite, tricalcium phosphate, and so on. And this material, you can produce it in vitro. Let's say big quantities with big quality. No need to take bone from cadaver. You can make synthesis of calcium and phosphate and reproduce the same material than bone. And afterwards, of course, we can also process it. By using a conventional process, we can make dense part, but we cannot, it's very hard to make, we can make also porous parts, but it's very complex to combine dense and porosity using conventional techniques. But 3D printing allows that. And by using that, we can really mimic the architecture of a bone, because the bone is made of a dense skin and a very high porous marrow. When we talk about bioceramic, yes, of course, we talk about artificial bone like hydroxyapatite, but this artificial bone can also be resolved, like using tricalcium phosphate. We can also mix both to play on the resorption speed. But we have also other ceramic, like bioglass, but also very hard ceramic, like for dental, zirconia, or heat-resistant aluminum. But today we will talk about hydroxyapatite and tricalcium phosphate. Now the theory, but afterwards the cases. We'll show you some applications where we are working for. And the first one is back pain. When you have severe back pain, the most common surgery is to fuse the two vertebral bones that are hurt. And for that, the most conventional technique is taking a plastic or metal piece and take the bone of the patient, insert that in the piece, and then the two vertebral bone can fuse using the bone graft that was inserted between the two vertebral bones. So here we see the two vertebral bone of the patient, the insert, and then the graft. But using additive manufacturing, 3D printing, we can avoid taking the bone of the patient by 3D printing a graft, a 3D bone graft made of different porosity, different channels, interconnected channels, allowing the bone of the patient coming from the vertebral bone, integrate and making the cell the same role than taking the bone of the patient. It's like a glue. And I can show you, maybe you can see that the 3D bone graft has different interconnected channels allowing the cells and glue the two bones. And it works. It really works. So we have printed more than 40,000 bone insert for this kind of application from another company. So, and you can see here that the bone fusion works, and you can also avoid like titanium plates, because the fusion is as good as taking the bone of the patient. You can see also a sample of this kind of cube with interconnected channels. So by controlling the porosity, and you can only do that by using 3D printing, you can really innovate in terms of implants. So then, afterwards, customer wanting to enlarge the application using the same approach. And the other application is all orthopedic for wages, because yes, we can have we are all different, and we can have also issue in legs axis. And to correct the leg axis, you need to cut the bone and then insert again a bone graft to correct the angle of the leg. And again, avoiding taking the bone of the patient is possible now using 3D printing. Using the same strategy, you can print a bone graft made of porous structure but also a dense structure. The porous structure is used for let the bone integrate the implant, and the dense structure is made for loading, because the leg needs to load a lot of kilos, and then using 3D printing you can do that. So we have printed different kind of hydroxyapatite tricalcium phosphate here wedges, and you can see that it's well tolerated, and after 2 years, because we use a mix of calcium phosphate, the bone can integrate but also regenerate, and the calcium phosphate can also disappear and let the place to new bone. That's really a revolution in this field. So you can make a standard implant, but you can also imagine that you could also make customized patient-specific implant. So using that, we want to explore other applications. That's what we did with dental. And maybe remember this picture about this famous politician, Italian politician, when he was hurt by a fan. He lost a tooth. But when you lose a tooth, you have a hole. And then, before regenerating a new dent by putting an implant, a screw, and a crown, you need first to regenerate the bone with the place of the lost tooth. So what you do, it's inserting kind of granules, a lot of small granules. It works, but it's not working so well, because we need to wait a lot of time to regenerate the bone within that. But in dentistry, that is really amazing, the technology that they have. They can really follow all the digital way by taking CBCT scan, really high precise CBCT scan, and planning all the different treatments. So they can plan the bone regeneration, after they can plan the screw and the crowns, and etc. So that's where we are working on with other companies and universities and also different physicians to take the CBCT of the patient, making the mandibular, and then modelize the bone graft missing, print it, and insert it quite perfectly within the mouth of the patient. Moreover, we have developed a new models, more implemented that the interconnected block that I have shown before. It's a mathematical model made of different interconnected pores where the cells are growing faster than the block that you have seen and faster than the granules that are sold at this moment. I can say that putting stem cells on this kind of scaffold is really amazing how fast the cells grow. You can see afterwards if you are interested. So when you have generated the new bone, you need to place also the screw, crown, and of course you can also do that by using 3D printing or bioceramic because the crowns and the bridges are made of ceramic. But I will skip that to go to the final subject, that's maxillofacial surgery.